Hello, the objective of this video is to learn about solving systems of equations by substitution method. And there are three possible cases to work with when you are working with solving systems by substitution. Case one, both equations are solved for either x or y. In this example, here we have the y is equal to 2x plus 3. They are solved for y. You got y all alone on one side, everything else on the other side of the equal sign. This one's the same way, y all alone on this side, everything else on that side. That makes these two solved for y. Or you could have them solved for x, which means you have x all alone and everything else on the other side. So you can either have them both solved for y or both solved for x. That's considered my case one. Case two, one equation is solved for either x or y. So in this case, this example here, we got the one equation solved for y, the other one isn't. We got the x and y on both on the same side here. Over here, we got the one equation solved for x, and the x and y are on the same side here there on this one. So only one equation solved for x, one equation solved for y. So either you have both or you have only one of them solved for one of those variables. Case three is when none of them are solved for either x or y. Basically, you'll have something like this, this one from the case two, and another one like this one from case two. When you have two of them like that, and then what's known as a standard form, there is a different way to solve. You would not really want to use substitution, but I will talk briefly about how to solve it by substitution if you absolutely must do. Okay, this screen is a screen of notes that I asked my students to take after taking their quiz today in class. So if you want to pause the video and write these down, you're welcome to do so, but I'm not going to go through this one in detail in the video here. If you paused, welcome back. Let's move on to the next screen. Okay, let's look at this first example here. Here we have two equations, both of them solved for y. They got a y equals something and a y equals something. Now, because they are in the mx plus b form, you might consider graphing, but most people don't have graph paper on them all the time here. So what I would do is I would look at solving by substitution. Now, according to the directions, it does say to set the two equations equal to each other. So I would set 3x plus 8 equal to 5x plus 4. Technically, what we're doing is we're taking this value of y and substituting it into this y. That's why they call this the substitution method, because we're substituting this value of y for this y. All right, and that's going to give us 3x plus 8 is equal to 5x plus 4. And we can do this because the properties of equality say that if this y and this y are the same, when those two equations cross, when those two graphs cross lines there, this y and this y are going to be the same value. So if this y and this y are the same, and this y says that it's 3x plus 8, then this y should also be 3x plus 8 when this one is when that one is the same value there. So we set the two equations equal. That's step one. Step two, we solve for x. So I subtract 3x. If I can get the 3x, subtract 3x, and I get 8 is equal to 2x plus 4. All right, then I continue solving there. I subtract 4 from both sides. That would give me 4 is equal to 2x. Then I would divide by 2, and I get x is equal to 2. Now that's half the answer right there. I still have to find the y. So according to step 2, I take that value of x and plug it into one of the original equations. So I'm going to plug it in for x in that first equation there. So this first equation, instead of being 3x, it's now going to be 3 times my x value of 2 plus 8, which is going to give me 6, which is equal to 6 plus, well, boy, my pen is more 6 plus 8, which is going to give me y is equal to 14. All right, so it looks like my answer, according to what I've done here, should be my x value is 2 and my y is 14. So I want to check that. So I go back to this second equation here, this one which I haven't used yet, and I plug in both the y and x values. So I have it originally as 5x plus 4, but now I'm going to replace the y with 14, replace the x with a 2, and if I simplify this, both sides, if I got the right answer, it should be equal. Well, 5 times 2 is 10, plus 4 does indeed give me the 14, so this does double check to give me the answer of, and that's where we write the answer, step 5 there. The answer is going to be 2, 14, and we should always box or circle our final answers. All right, now let's look at this second equation, second system of equations here. We have 3x minus 6 and 3x plus 2. So we set those two equal. 3x minus 6, set that equal to 3x plus 2. All right, now I'm going to subtract 3x from both sides because I'm solving for x. So I subtract 3x from both sides. I get a negative 6 is equal to 2. It cancels on both sides. Well, wait a minute. How can I solve for x if x disappears? Well, when that happens, when you get the variables dropping out and the two numbers are not equal, because negative 6 does not equal 2, then what you have is an answer of no solution. Why is it not letting me write? Solution. No solution. Now, when this happens, it's probably because these two lines are parallel lines. And they do both have the same slope, but different y-intercepts. So if I were to graph these, they would probably show, they are going to show up as two parallel lines. So they will never cross, and therefore there is no solution. Now, in my directions there, I did say it's possible that both equations could be solved for x instead of both being solved for y. And here's a case where we have x equals something and x equals something. The process would still be the same. We're going to set both equations equal to each other. So we start off by doing 3y minus 4 is equal to 4y plus 2. All right, then I solve for y here, kind of the opposite of solving for x. I'm going to solve for y first. So I'm going to subtract 3y from both sides because I need to move the variable to one side. It's going to give me negative 4 is equal to y plus 2. Because 4y minus 3y gives me just plain y. Then I subtract 2 from both sides. Oops. Subtract 2 from both sides, and I get negative 6 is equal to y. Now that I have y, I should be able to find x. So I go back to one of the original equations. I usually like to work with the first one, and I substitute in this y value, substitute it in for the y value up here to solve for x. So I have a 3 times negative 6 minus 4. All right, then 3 times negative 6 is going to give me a negative 18 minus 4, which gives me x is equal to negative 22. Now I should be able to double check my answer by plugging these into the second equation. So instead of being x equals 4y plus 2, I'm now going to have a negative 22 for x and a negative 6 for y. And this gives me a negative 24 plus 2 on this side, which does indeed work out to be negative 22 equals negative 22, so that double checks. So my final answer is going to be the x value, negative 22, comma, my y value of negative 6 in a set of parentheses, and you box or circle your final answer. All right, so it's very important that you do box or circle your final answer, especially with all of this work going on here. It's very difficult for someone to see what your final answer is if you don't box or circle it. All right, here are 3 problems that you should pause the video and try them yourself, and then I'll pop up the answers. All right, welcome back. We're going to take a look at the answers now. Okay, so here are the answers. Hopefully you got those right. If not, please send me a comment. I'll go see if I can do a second video where I go over the work on it. I do want to point out the fact that just because this is a y equals 8 does not mean you should do anything differently here. It's still going to be set them equal, so it'd be 8 equals 5x minus 2, and you'd solve for the x there. Here, just because there is no y-intercept, doesn't change anything there. It's still going to be start off by negative 3x is equal to 3x plus 6. Okay, and that is a plus, if it'll let me write, plus 6 on the end of that one. Okay, when you go on to case 2, case 2 is when there's only one equation that's solved for x or y. Assuming the one equation is solved for y, these directions are going to assume that, and if not, where I say y, use x, and where I say x, use y. So these directions will apply for whether the equation is solved for x or y. We're going to assume that they're solving for y. That's the way I've written these. If they're both solved for x, you're going to do the same thing, but wherever I say x, you would say y, and wherever I say y, it should be an x. So we're going to substitute the equation solved for y into y for the other equation. Solve for x. Substitute your value of x for x into one of the original equations, then simplify to find y. Check your answer. Write your answer as a coordinate pair. These last parts are very similar to what we had before. They're really the same. But the best way to see this is in an example. So let's look at the example. Okay, now on this first example, you see we have one equation solved for y, the other one is not. So we're going to start off by substituting this value of y in for y in this equation. So now this becomes a negative 2x minus 6 times x plus 6. So instead of being a negative 6 times y, it's now a negative 6 times the x plus 6. We still have the equals negative 4. Okay, then we need to distribute the negative 6 to both terms there, and we're going to get a negative 2x minus 6x minus 36 is equal to negative 4. Now we continue to solve by combining like terms. These first two terms are going to combine to give me a negative 8x minus 36 is equal to negative 4. Then I would add the constant to get it to the other side, and I would give me negative 8x is equal to a positive 32. Then we divide both sides by negative 8, which gives us an x is equal to a negative 4. Okay, now I take that and I go to my original equation. The original equation is a y equals the x plus 6. I now replace the x with the -4. And when I do that, I get y is equal to 2. So now I have my x and my y. That is my solution. So I do believe my solution should be a -4, 2. And I can double check that by plugging those both into the second original equation here, which is going to give me a -2 times the x value of -4 minus 6 times the y value of 2, and that should be equal to -4 if I've done this correctly. Now, -2 times -4 is going to give me a +8. This gives me a -12. And 8 minus 12, minus 12 does give me a -4, which does double check. Now let's look at this second example here. At this second example, one of the equations is solved for x. So for this one, I'm going to take this value of x and plug it in for x in the second equation, or the first equation there. So this can become -3 times 4y minus 8 minus 4y is going to be equal to 24. Then I would distribute the -3 to both of these terms, which is going to give me a -12y plus 24 minus the 4y is equal to 24. Then I combine my two like terms here. It's going to give me a -16y plus 24 is equal to 24. Then I would subtract 24 from both sides. So I subtract 24, subtract 24. I get -16y is equal to 0. All right, so now I would divide both sides by -16. And we should know that 0 divided by anything is going to give me a 0. So half my solution is y equals 0. Now I take that 0 and I plug it back into this equation to find my x value. Okay, so I'm going to have, let's change the color here to make it a little easier to see. We're going to have x is equal to 4 times 0 minus 8. This is going to cancel out. You get x is equal to -8. All right, so we have our answer. We believe our answer is going to be a let's put it in purple there, -8, 0. And to double check it, we would put it into the original first equation here. We have a -3 times -8 minus 4 times 0 is equal to 24. And this cancels out. This does equal 24. So we do double check and we're good there. Don't forget to box or circle your final answer. In this example, we have one equation solved for y. So we're going to take this value of y and plug it in for y here. This will give us -21x plus 3. Now instead of being times y, it's going to be times 7x plus 11, and that's going to be equal to 33. I do apologize for the really horrible writing here. Apparently my iPad is not letting me write with a stylus or my finger right now, so I'm doing my best to finish this video before the weekend. All right, so we now need to distribute this 3 to both terms here. So after distributing the 3, you're going to get this. You get negative 21x plus 21x plus 33. And the 21x and negative 21x will cancel, which will leave you with just 33 equals 33. When that happens, when the variables drop out and both sides are equal, you have what is known as infinitely many solutions. And that would be your answer here, so you would box or circle it as your final answer. This answer is not going to be coordinated, it's going to be infinitely many solutions. Okay, this is your chance to try these on your own, so pause the video, try these two. Welcome back, and here come your answers. So here are your answers. Note that this one worked out to be no solution. They're parallel lines. You may want to pause the video and check your answers a little bit longer here. I'm going to move on. Okay, the third case is when you have neither equation solved for x. When that happens, you generally want to use a method called elimination. If you are forced at gunpoint to solve using substitution, then solve one of the equations for y and follow the steps for case 2. Now, the next screen, I had planned on doing some examples of solving for y, which I'm going to leave in the video here because I do hope to finish this up and maybe rerun it. But I'm not going to be able to record that today before putting out the video. So, again, if you happen to get neither equation solved for x or y, you're better off using the elimination method. I won't be giving anything like that in my class. When you have them, neither one solved for x or y, you're better off just using a different method. Okay, I would like to go into this one. Unfortunately, I have run out of time in my day here, so just know, I will hopefully add this to a video and rerun the video later.